Hello, I am Dr. Ajay Sharma, Department of Electronics and Communication Engineering, James Engineering Management Technical Campus. The subject that I teach in this fifth semester is digital communication, and the topic that I will discuss today is quantization error and quantization noise. Now, try to understand quantization error. In previous lecture, uh, we had go through this quantization process where we have to approximate the voltage level of the samples. For example, if we have a sample of 3.4 volt, we have to what we do, we have to approximate as 3 volt. If we have a sample of 4.8 volt, we have to approximate as 5 volt. So when you approximate, approximate the particular sample by assigning a very real value, the error come in the picture. For example, if you approximate 4.8 volt as a 5 volt, then 5 minus 4.2 is equal to 0.2 volt. So this 0.2 volt is a quantization error, right? So in quantization process, if you take a step size of 1 volt, then there is a possibility of error whose range start from 0.1 volt to 0.5 volt. Clear? Right? So the difference between an input value and the quantized value is called as quantization error. For example, if you have a 3.8 volt, this is your input value. Now you quantize this as a 4 volt. So the difference 4 minus 3.8 is equals to 0.2. We are talking about this difference. So difference between an input value and the quantized value is called as a quantization error, right? So a quantizer, and what is quantizer? What is quantizer? Quantizer do quantization process, right? So a quantizer is a logarithmic function that perform quantization. And what we did in quantization in previous lecture, we round off the values. How we round off the values? 3.8 become 4 volt, 4.3 volt become 4 volt, 5.2 volt become 5 volt. So this is the quantization round off value, right? So an analog to digital converter work as a quantizer. So quantizer is nothing but it is a converter, analog to digital converter, right? Now this look at this figure. The following figure illustrates an example for a quantization error. Indicate the difference between original signal and the quantized signal. So in this particular picture, we have two signals. One is original signal that is shown by a blue shade, and we have a quantized signal, have a shade of red shade signal, right? So although this quantized signal follow your original signal, but we can't say that both are equal, right? Because the shape of blue signal, which is called as the original signal, is just like a sinusoidal type of signal, but the quantized signal is a staircase signal, right? And a staircase signal defined discretely rather than all time based. As far as original signal is concerned, that is defined at every moment of a time. So so the two signal, if you see the two signals, sinusoidal signal and this red zigzag, or you may say quantized, or you may say staircase signals, it's not look the same. But this is true that this quantized signal follow your original signal. right? And if you have a step size of 1 volt, then there is a possibility of error which lies between 0 to zero point 0.5 volt, right? 0 volt means if you have a sample luckily at 4 volt, so 4 volt become 4 volt, so there is no error. So we say that the quantization error is 0 volt, right? That's why we say the range is between 0 to zero point 0.5 volt. So in this it is a type of quantization error which usually occur in an analog audio signal while quantizing it to digital, right? So whenever this error quantization come in the picture, whenever you have some analog signal and you have to convert this in digital signal with the help of quantizer. So the signal keeps changing continuously where a regularity is not found in error. Such error creates a wideband noise called as a quantization noise. So in this process, when the quantization error come in the picture, this quantization error creates a quantization noise. Thank you.